Alright, so just like solving a simple equation, division of matrices is not defined, so I can multiply both sides by the inverse of this number to get rid of it so that I'd be left down here with a 1x. Now, here's a cool thing to think about too. When you're dealing with real numbers, numbers on the number line, multiplication is commutative, right? So I can do that negative 1/3 over here on the right hand side, even though over here I did it on the left hand side. It wouldn't matter when I'm dealing with real numbers. But is multiplication of matrices commutative? No. So if I multiply this side by the inverse on the left, I gotta squeeze it in right here. I gotta do it on the left on this side also. That's the only difference that there is with real numbers and with matrices. How am I going to find the inverse of this? Remember, we just did it. What is the determinant of this matrix? 12 minus 20. What would it be?
-8.
-8. Alright, I'm still working on the inverse now. I would switch these two, and I would change the signs of these two. Switch these two, change the signs of these two. Now this represents A inverse. If I multiply, let me change colors here. Now this part is the original problem. This is the original problem. If I multiply this matrix, if I multiply this matrix times its inverse, what will I get? What did I get before?
1, 0, 1.
That any? Do I really have to show you that, or do you believe me? Didn't we do it before? Every time you multiply a matrix times its inverse, you get that. Okay? Now, what I do to one side of the equation, what did we learn early on? What I do to one side, gotta do the other side. But I've got to be really extra careful with matrices because it's not commutative. So I've got to squeeze in this 1 over my determinant. I've got to do all this inverse stuff right here on the left, just like I did on the other side of the equation. And then remember, this red part, remember, that's just my original equation. And this black part here, this is my inverse. This is what I did to both sides. You see it? This is my original equation. This is multiplying both sides by the inverse. Now, I know what that's going to give me. That's going to give me the identity. All right. You always save your scalar to the end because do you really want to multiply all these by 1/8? Me neither. Okay. So let's multiply across and down, and that would be -12. Is there a built-in plus or minus sign when you're multiplying? Plus. So -12 and -12 is -24. And then -15 minus 9 is, just so happens, -24. Worked out beautifully. It's our first example. It has to be easy, right? Alright, what is the identity times anything? You told me a while ago. If I multiply a matrix times the identity, what do I always get? Itself. That's the variable I was solving for. Now, what if I multiply this by 1/8, or in other words, divide it by -1/8? What will I get? And that's confusing because that's what I started with up at the top, but that has nothing to do with it, okay? Now, let's go back to thinking about, I have equal matrices. Is it a 2 by 1? This is a 2 by 1. What is x equal to? What's y equal to?
3.
So wouldn't this be 3, 3, consistent, independent? Y'all know where we are?
No, not at all.
Not at all?
I got the first
You got
one.
some people shaking yes, some people like, what? So let's practice again, okay? Let's do it.
Yeah, did it.
What was that? No, that's the same number here.
Yeah, that was
How about that one? That's numbers like y'all like, big ones. 22. Alright, first of all, let's practice. Let's write this as a matrix equation. Alright, here are my coefficients. here's my variable column matrix. Is it okay with y'all, since I've got to squeeze the inverse in here, if I let you enough space to do it? You people that only listen intermittently, you know, it's not your windshield wiper. Y'all are in and out, in and out. Is it okay if I leave space here? Cause I'm gonna have to put my inverse there anyway. So I'm gonna skip over here and do my constant matrix. Is that okay with you? Alright, now, I have to find the inverse of this one because this is the one I'm getting rid of, right? Cause what do I eventually want?
XY.
My XY. Okay, so what's the determinant? Negative 14 minus 15. Agreed? Switch those two. Change the signs of these two. This is what I just did to this side of the equation. So I must do the same thing to this side. Are you lost yet? Be honest. So there's my determinant. Alright, what will I get every time I multiply a matrix times its inverse? The I word, the identity, right? Yes, 1, 0, 0, 1. Alright, I'm gonna say my 129, till the end. Goodness, I don't want to multiply that by negative 129. Alright, so row by column. Negative 6 minus 110. Negative 9 plus 154.
Get rid of that again, please.
Sure. Crossing down. Negative 6 minus 110. Yeah. And then switch rows. Negative 9 plus 154. What is the identity times the variable? The variable. Alright, you guys have got the calculators. What's negative 1/16 divided by negative 29? What is 145 divided by negative 29? Yeah, it would be positive. Good job. I didn't even notice that. I got two negatives, guys. That would give me a positive. Alright, 145 divided by negative 29. Is that negative 5? So what's x? 4. What's y? Negative 5. This was a consistent independent system. If I graphed it, that's where they would have intersected. Alright, yes.
Where did you get the 160?
Okay, crossing down. Negative 2 times 3. Negative 5 times 22. If I put those together, I get negative 110 and negative 6 would be negative 116. And then across and down, negative 9 plus 154 would be 145, and that went here. All right, here's a point to think about. What kind of systems would not work with this method?
Zero.
Yes, they would have a determinant that's 0. What? Inconsistent or consistent dependent. That's right, because wouldn't they be the same equation if they were consistent dependent, and how they give you determinant 0? So what would you have to back up and do? Well, you would know, first of all, if it had a determinant that was 0 and didn't have an inverse, that it's not going to be consistent independent. So at least you know that. And then you just have to decide if it's inconsistent or consistent dependent. And weren't those the easiest ones to solve with substitution and elimination anyway? Because everything canceled out. You either had a true statement or a false statement.
So if it one of those, it's gonna have a 0.
As a determinant. And you could not do it this way. Yes, Jeanette? Okay. All right, look at your packet. And you are already Okay, on the back of the page you're looking at right now, there are 8 problems that say solve using matrix equation. That's the only 8 I want you to do.
Do like easy.
There are only 8.
But it takes so long.